Good afternoon, and welcome to this podcast on how to read journal articles. In a field like computational chemistry, a field that is relatively new compared to other areas of study, especially in science, you won't find as many textbooks that you can read to learn about methods and different aspects of computational chemistry. Most of the information that you're going to want to get about computational chemistry is going to be found in the professional literature, otherwise known as a journal article. So this podcast provides a brief introduction to how one goes about reading a journal article. In this course, you'll get a number of journal articles to read, and you probably understand right at the beginning that you cannot read a journal article like you would read a novel. You don't start on page 1 and read straight through until you get to page 15 or 16, whatever the case may be. Journal articles need to be attacked, if you will. They need to be analyzed, and the reading that you do has to be a lot more active. One of the good things that I hope you learn out of this podcast is that it's not always necessary to read the entire journal article. So we'll talk about that first. Okay, so the article that you're being asked to read for this week's session comes from the Journal of Computational Chemistry, and that's the premier journal in our particular field. This first article that I'm asking you to read is called Charge Distribution in the Water Molecule, A Comparison of Methods, and it's by Martin and Zipse, and they're out of the Department of Chemistry at LMU in Munich, Germany. Okay, how are you going to read this particular journal article? Let's look up in the top left-hand corner what I've done for you for this first journal article. I won't do this for the other ones, but what I've done for you in this journal article is I've added some annotations to help get you through this article. Okay, starting in the top left-hand corner, look in the little post-it note type of thing. This is my recommended order for reading. The first thing you always want to read is the title, and you're being asked or required to read this particular article, but typically when you read the title, that gives you an idea of, is this article interesting to me? Is this something that I think will be useful to me? Is this an article that I think will be worth my time? If the answer is no, then you don't go any further and you move on to the next journal article. The second thing you're going to read is what's called the abstract, and in most professional journals the abstract is going to be anywhere from 100 to 300 words, and the abstract should tell you in a very concise form what it is the authors were trying to accomplish, what their research question was, a little bit about what their methodology was, perhaps a little bit about what they discovered, and if it's a particularly good abstract, they would say where their research is leading them and what they might do first. So at the very beginning, you're going to read the title and the abstract, which are right up front. Then what you're going to do is you're going to jump to assuming that the abstract is interesting, you're going to jump to the very end of the article and you're going to read the conclusion. And this is where it's not cheating to jump right to the conclusion. So you go to the conclusion and you try to figure out, okay, what was it they learned? What did they discover? What do they think is true? Okay. After that, you're not going to read it all. You're really going to look at the graphs and the data tables. And of course, I would recommend you start with the graphs. The graphs are really where the authors are summarizing their data, what data they collected. This is where they're trying to do their analysis work. So it's really important to spend some time with the graphs, especially I would recommend you read the captions, make sure you understand what you're doing, and you can't just look at a graph. You really have to study it and dissect it. Okay, so at that point, after step number 4, you almost can, if you think you've gotten out of this journal article what you think you need to get, you really can stop now. You don't have to read anything else. Assuming, though, you want to keep on going, and I will ask you to do so for this first week, and this may surprise you, the fifth thing you want to read is the literature review. You want to go all the way to the back and start reading through the list of other journals and other people that were referenced in this particular article. And especially in computational chemistry, which is a relatively small group of people as compared to other areas of scientists, you're going to start seeing the same names pop up over and over again. You're going to see Tom Dunning, you're going to see Parr, you're going to see Yang, you're going to see a lot of names that appear all the time, and it's important to start making a note of who these people are and what their contribution is to the field. Now, the sixth thing that you would read, and I might have to put a little asterisk next to this one, but the sixth thing you would typically read would be the introduction. And you might ask, well, why don't I read the introduction first? It's actually the case as a beginning scientist, as a beginning computational scientist, you might actually need to read the introduction earlier than you might normally if you are a experienced practicing scientist. The introduction generally lays the foundation. It says, okay, here's the background information you need to know to read this particular article, and most of the time you already know this background information. You've been working in this area for a long time. You don't need the introduction to tell you some of the basics of what of the background science, if you will. At the beginning, however, you might need to read this a little bit more thoroughly than you might later in the field. Results in discussion would be the seventh thing that you would read. Most of the time the results in the discussion has been summarized up here in the conclusion, so you can, if you want a little bit more in depth, you could read this. And the last thing that you would read would be the methods and the procedures. And you would only read the methods and procedures if you think you want to try to replicate what these authors are trying to do, or if you're looking for trying to figure out what method they use to solve a particular problem. Okay, so running down through the article, what I again have done is I've tried to annotate some of the things that I've just mentioned. I talk about here how the title will go through and give you a clue that something might be of interest, what the abstract does, what the introduction does, and for this particular article, to be able to read this particular article, I've highlighted some things here in the introduction. Again, if you go back up to the title, what these authors are trying to do is they're trying to figure out how is electron charge distributed in the water molecule. Now, you may know from freshman or from beginning chemistry, we typically say that oxygen has a charge of -2. We tell you that hydrogen has a charge of +1. We tell you the other hydrogen has a charge of +1. And if you add those three things up, you get a charge of 0. Well, that's the periodic table definition of the charges on oxygen and hydrogen. It turns out actually when we really look at oxygen and hydrogen, that the charges are not integer numbers like -2 and +1. So down here I've highlighted in the introduction what they think the charges are. So these authors are saying that we believe, and the Q there means charge, that the authors are saying that we believe the charge on the oxygen is -0.66 electrons, okay, and that the charge on the two hydrogens is 0.33. And again, because you have two hydrogens, 2 times 0.33 is 0.66. You add them up, and you still get a net charge of 0 for the water molecule, which is what we'd expect. It's important that you know that they're assuming that the -0.66 number on oxygen is the correct answer, because again, what they're trying to do here is compare their methods. Okay, so they're telling you we think -0.66 is the right answer, and now what they're trying to do is they're trying to say which computational method best obtains that value of -0.66 on the oxygen molecule. Okay. All right, so if you read through the abstract here, you'll see what methods are being compared. I will leave that to you to do that. Again, typically you would not read the methods section unless you probably do want to get in the habit of that in the early stages, because you don't know how to do anything yet in computational chemistry. And so it is good to start looking through that. One of the things I may get you to notice here, and this is something to keep a very good eye out. I'm going to highlight this here, and I'm going to highlight this right here. notice that it says all calculations have been performed with Gaussian O3, which is one of the pieces of software that you have at your disposal. It's a very good idea in the early part of your career to start looking in the method section, and if nothing else, just simply find out what piece of software they use to solve the particular problem. Again, I would skip the results and discussion, but I would pay an awful lot of attention to these graphs here. Now, what I've done here is I have circled in red, and that's my notation that was not in the article, that the correct answer is minus 0.6. So that's the target. And what you see from this graphic right here, whatever these methods are, and you'll need to read a little bit about this to figure out what they're talking about, that none of these methods got very close to the correct answer. Scrolling down a little bit, if I look at this graphic, likewise with this method here, notice that our answers are a little closer together. They're not so scattered about as they were over here, but they're still, that line there still doesn't match the minus 0.6. If I scroll down here, again, I didn't put a little circle around it. I guess I could do that. Let me go ahead and do that. Okay, so let me put a little circle right around there, and let me put a little circle right around here. Okay, again, these are all assuming that these are all the correct values here. Okay. What you should notice here is, for whatever these methods are, and again, you will need to read a little bit about this, that you're a little closer here to the correct answer. So whatever this STO3G thing is, okay, that's getting pretty close to the right answer. So what this should tell you is that, okay, whatever these methods are here, okay, do a lot better than whatever these methods are up here. And you might want to read a little bit about what these particular things are. Okay, so again, looking at the graphs is really quite helpful. Now, okay, there's a lot of data in this particular thing, and what I did is I highlighted here, and again, it's really important that you make sure that you read the caption so that you understand what they're talking about. And if you read that, it says the partial charge on the oxygen atom in water. Okay, so again, knowing that minus 0.66 was the right answer, if I try to look through this data, do a quick look through this data, actually let me see if I can do a markup here. Yes, I can. Let me put, okay, whatever this method is right here, okay, whatever this method is right here, does a pretty good job of getting close to that minus 0.66. So are there any that are any better? Now, that's probably pretty close to the best one. So again, just doing a quick run through of the data here is sometimes a helpful thing to do. Okay, at this point I would jump all the way back to the conclusions, and this particular author does a very nice job in his conclusions of listing in 1, 2, 3, 4. That's a very nice way to have done this. He lists in in a list fashion what his conclusions were, and that's really quite helpful to do. He continues these over on the next page, okay, and that makes it really particularly helpful. Okay, so jumping to the conclusions is a very good idea. All right, at this point, okay, and at this point you could pretty much stop reading the article. If you want to go back and read through the results section, the discussion section, you could do so. You could go and you could read through the computational methods and figure out how they did it. You could read the introduction to get a little bit more idea. But again, this is, I encourage you to pay very close attention to the references or the literature cited paper. You're going to see things like, I'm going to highlight some names here. Okay. So H-E-H-R-E, Warren Henry, is really important. A guy named Popel, okay, is very important. You're going to see Beck a lot. Okay, I'm gonna mark that up. Okay, you're going to see Lee, Yang, and Parr. All of these are local people. These are all North Carolinians. Okay, Bob Parr is at UNC Chapel Hill. Wei Tao Yang is at Duke. Cheng Tae Lee is now actually out at Cray Supercomputer. Okay, you're going to see this notation, this very long notation right here. Okay, I'm going to highlight it. I'm going to highlight part of the other stuff as well, but pay attention to this stuff over here. This is the notation for the Gaussian code. Okay, you're going to see Tom Dunning, a good friend of mine. He's out at the University of Illinois. You'll see his name mentioned a fair amount. The other thing that you also want to take a look at in the reference section is what journals are cited. Okay, so you'll see Annual Review of Physical Chemistry. You're going to see, and we'll have a chance to talk about this a little bit, you'll see things like the Encyclopedia of Computational Chemistry. So you'll see books like Jensen's Introduction to CompChem, Chris Kramer's Essentials of CompChem, those types of things. So it's really important that you get to start looking at the literature, because when you start to do your own research and want to be doing your own work, it's really good to know whose stuff should you be reading and whose stuff might you be able to ignore. You see, by the way, okay, Warren Henry gets mentioned again. Tom Dunning gets mentioned again. So you should get a sense of these people whose names are getting mentioned more than once. There's Reed's name mentioned a couple times in here. So it's really important to be able to get to do that. Okay. Now, okay, what I'm going to ask you to do as a way to, so you're not just trying to read this article. If you just try to read it, it's going to put you to sleep. You're going to get bogged down. You're going to get lost. So you got to read it actively. So as a way to do that, what I'm asking you to do is I'm giving you a journal article evaluation form. You're going to type the name of the article. So that's going to be something like, you know, charge, if I could type, okay, charge distribution, etc. You're going to put the author's name. You're going to put the Journal of Computational Chemistry. Okay, you're going to put the issue date. You're going to put what pages it's on. It's on pages whatever it is. You're going to put your name. You're going to put the date. Okay, and then what you're going to do is you're going to read the abstract. Okay, and you're going to try to restate the abstract in your own words. It doesn't need to be sophisticated scientific language. Tell me what the abstract is telling you. Okay, down in the introduction, okay, you're going to pick one or two sentences, and that's all. One or two sentences that you consider to be the most important, and you identify them by page, by column number, and the first 4 or 5 words, and then you describe why this sentences or these two sentences are your choice. Okay, there's no right answer there. Okay, I'm interested to see what you think is the most important sentences. Okay, if you can find, now there's no section called research question. Okay, but what you want to try to do is you want to try to identify what are the authors trying to do here? What question are they trying to solve? So basically is, okay, what question are they trying to answer? That's what you're trying to do here, okay? And most of the time the answer, the question they're trying to answer should be the title, so that should be helpful, okay? Research method, again, you typically, unless you wanted to replicate this, you wouldn't read the method. But I would like you to get in the habit of reading, start now, read the computational method or the research method, and try to describe in your own words how the researcher did it. It's going to be hard at first because you don't know a lot, but certainly you would say something, they used the Gaussian software. Okay, so there's one thing you're going to say in your research method. Okay, all right, in the results and discussion section, what you're going to try to do here is identify the take-home message. And what you're trying to do here, what is the most important result, conclusion, etc. that came from this article. Okay, and since this is a comparison of methods, okay, you're going to probably answer the question, which method was the best kind of thing, okay? All right? And I'm also going to ask you to identify one table that you consider, now table means a data table, okay? Identify one table that you consider to be the most significant and or the most useful. Most useful to who? Most useful to you, okay? Describe what the data in that table tells you and identify why you picked this table. Likewise, do the same thing for a graph. Identify one graph that you consider to be the most significant or useful. Describe what the data in that graph tells you, and tell me why you picked that graph. And lastly, and this will be hard at first, intended audience. Identify who's the target audience for this article. Is this for somebody who wants to learn how to do computational chemistry? Is this somebody who's only interested in some of the theories of computational chemistry? Is this for both those people? Is this for somebody else? Try to figure out who was the audience for this article. Who was this article written for? Describe who that audience is. So basically you're saying, okay, who is the audience? Okay, and then why do you think this is the case? Okay, and so once you've done this journal evaluation tool, then what you might want, then you would save it and you'll upload that and send that to me and I'll take a look at it. One more thing that you can do, we talked a little bit about concept maps as a part of this course, and I decided to not do concept maps for a little while, and what I'm doing right now is loading up a concept map. But oftentimes what I will do is I will build a concept map for a particular journal article. I have a program here called CMap Tools, and you see here there's a CMap called Charge Distribution in Water. And what I've done with my concept map is I've basically built a map. So charge distribution in water molecule primarily looks at the methods evaluated. I put over here a little note about where it came from. Okay, I said the keywords are important. The keywords were charge distribution, water molecule, and quantum mechanical methods. Okay, and I said the methods evaluated, it looks at 4 quantum mechanical methods. It looks at a population analysis method. From my introduction, I learned a little bit about what these population analysis methods are. And somewhere down here, I have a results section. Over here, I have a results section. So a concept map is oftentimes a good way to evaluate or analyze a journal article. The nice thing about this, by the way, is that you have one piece of paper that captures that entire 13 or 14 page journal article. It's a lot easier to look at one piece of paper than to go back and have to read the whole journal article. So I make these concept maps for many of the journal articles that I read. I put them in a book or I have them stored on my computer, and then when I need to refer back to a particular journal article, I don't need to look at the article. I look at the concept map, and that's all I need to do. Okay, I hope that's helpful. So for this week, what you're going to be trying to do is you're going to try to read this journal article. You're going to try to use some of the techniques that I mentioned. I would encourage you to pay close attention to these little post-it notes that I put on here and some of the highlights that I've added on here. And I'll be very interested to see your journal article evaluation form. During the video conference session this week, the main topic of the video conference this week will be to discuss this journal article. So I hope you read it. I hope your evaluation form is ready to go. And good luck with your first journal article.